Welcome to aminacademy.com. In astronomy, let us discuss about the structure of the atom. The idea that matter is composed of tiny particles called atoms is at least 25 centuries old. It took until the 20th century, however, for scientists to invent instruments that permitted them to probe inside an atom and find that it is not as had been thought hard and invisible. Instead, the atom is a complex structure composed of still smaller particles. Atom, a fundamental building block of matter, consists of positively charged nucleus containing protons and neutrons, surrounded by negatively charged electrons in shells or orbitals. Here's more detail about the breakdown. Nucleus, the central core of an atom containing positively charged particles that determines the elements of identity, that is protons. Neutral particles that contribute to the atom mass, electrons. Negatively charged particles that orbit the nucleus in specific energy levels or shells. Isotopes, atoms of the same element that have the same number of protons but different number of neutrons. Atomic number, the number of protons in an atom's nucleus which defines the element. Mass number, the total number of protons and neutrons in an atom's nucleus. Electron shell or orbitals, regions around the nucleus where electrons are likely to be found. Empty space, most of the atom is empty space, with the nucleus being very small and dense compared to the overall size of the atom. Electromagnetic force, the force that holds the negatively charged electrons to the positively charged nucleus. Bohr model, Niels Bohr proposed a model of the atom where electrons orbit the nucleus in specific energy levels or shells. Now, probing the atom. The first of these smaller particles was discovered by British physicist James J. Thomson in 1897, named the electron. This particle is negatively charged. It is the flow of these particles that produces currents of the electricity, whether in lightning bolts or in the wires being to your lamp. Because an atom in its normal state is electrically neutral, each electron in an atom must be balanced by the same amount of positive charge. The next step was to determine where in the atom the negative charges are located. In 1911, British physicist Ernest Rutherford devised an experiment that provided part of the answer of this question. What is that? He bombarded an extremely thin piece of gold foil, only about 400 atoms thick with a beam of alpha particles. Alpha particles are helium atoms that have lost their electrons and thus are positively charged. Most of these particles pass through the gold foil just as if it and the atom in it were nearly empty space. About 1 in 8,000 of the alpha particles, however, completely reversed direction and bounced backward from the foil. Rutherford wrote, "It was quite the most incredible event that has ever happened to me in my life. It was almost as incredible as if you fired a 15-inch shell at a piece of tissue paper and it came back and it hit you." This is called Rutherford experiment. Now we will discuss further about probing the atom. The history of probing the atom involves a fascinating journey from the ancient philosophical ideas to modern scientific instruments, with key figures like Democritus, Dalton, Thomson, and Rutherford laying the groundwork for our current understanding of atomic structure. Democritus, in 4th century BC, a Greek philosopher who proposed that all matter is composed of tiny invisible particles called atomos, meaning uncuttable. John Dalton, in 1803, an English chemist who reviewed an idea of atoms and developed the first atomic theory, stating that atoms are invisible and combine in simple ratios to form compounds. The dawn of scientific investigations. J. Thomson, late 19th century, discovered the electron, demonstrating that atoms are not indivisible and are composed of smaller negatively charged particles, leading to the plum pudding model of the atom. Ernest Rutherford, early 20th century, conducted the famous gold foil experiment, already we discussed, which revealed that atoms have a small, dense, positively charged nucleus, leading to the nuclear model of the atom. Niels Bohr, early 20th century, proposed that electrons orbit the nucleus in specific energy level, explaining atomic spectra. Modern probing techniques, field ion microscopy in 1950s. Erwin Mueller developed the field ion microscope, allowing scientists to visualize individual atoms on a surface. Atom probe field on ion microscope. Mueller and his co-worker invented the atom probe, which combined a field ion microscope with a mass spectrometer, enabling the identification of individual atoms. Scanning tunneling microscopy, STM. This technique allows scientists to image surface at the atom level and even manipulate individual atoms. Atom probe tomography, APT. APT is a technique that can map out the spatial distribution of atomic species in 3 dimensions, proving unique information about nanoscale structure. Now we'll talk about atomic nucleus. Atomic nuclei consist of electrically positive protons and electrically neutral neutrons. These are held together by the strongest known fundamental force called the strong force. The nucleus make up much less than 0.01% of the volume of the atom, but typically contains more than 99.9% of the mass of the atom. That means it occupies 0.01%, but it contains 99.9% of the mass of the atom. So far we discussed little about the atomic structure, which is used in study of astronomy. If you have done, please subscribe our YouTube channel. If you have done, please subscribe.